The M1 Abrams is the main battle tank of the United States Army. It's regarded as the most powerful tank in the world, even though its design is nearly 50 years old. But have you heard about Russia's latest tank? The much-touted T-14 may be the first tank in the world who can go head-to-head with the American Abrams and win. In fact, the T-14 has been heralded as an Abrams Killer. Others have called it an Abrams Assassin. It's a radical departure from the traditional tank design in many ways, especially the thought process that bigger is better. Not only that, Russia has said goodbye to a manned turret and instead protects its crews in a special armored compartment sealed off from the rest of the tank. As we'll find out in this video, other unusual features on the T-14 might allow it to surpass the Abrams as the baddest tank in the world. Before we begin comparing the two tanks, let's look at the evolution of the Abrams and how it became the most dominant tank in the world. The M1 Abrams was designed by the United States in the early 1970s to replace the M60, which served as America's main battle tank throughout much of the Cold War. It was upgraded time and time again to try and keep pace with the Soviet Union, but that was not an easy task. In the 1960s and early 1970s, it seemed like the Russians were introducing a new tank every other day. First, the Soviets introduced the T-62 in 1961. 3 years later came the T-64, and in 1973, Russian tank technology took a huge leap forward with the T-72. With the introduction of the T-72, it was becoming increasingly clear that the American M60 was past its prime. Something needed to be done, and fast. The first attempt by the United States was the MBT-70, which was a joint effort between the United States and West Germany. It was to have a massive 152mm gun launcher that could fire both conventional ammunition and long-range Shellelek-guided anti-tank missiles. It also had a 22mm autocannon mounted on the top of the turret and a 7.62 coaxial machine gun. The MBT-70 packed a wallop, but it was not to be. Design and other disagreements led West Germany to abandon the project in 1969, leading to the development of the Leopard 1. The United States continued development on its own for a while, but abandoned the MBT-70 project in 1971 due to cost overruns. The United States went back to the drawing board to come up with a new tank that would surpass Soviet designs. The new tank was the M1 Abrams. The M1 Abrams is named after Creighton Abrams, a former Army Chief of Staff and commander of the 37th Armored Battalion during World War II, where he served under General George S. Patton. Patton was incredibly impressed by Abrams. He was so highly regarded that Patton once said, "I'm supposed to be the best tank commander in the Army, but I have one peer, Abe Abrams. He's the world champion." Development of the M1 Abrams began in January 1971, when the US Army established a task force to develop a new main battle tank. The Pentagon began by laying out the requirements for the third generation of American tanks. It specified weight, width, and cost. The weight should not exceed 58 tons. The width could not be more than 12 feet. And finally, the tank should cost no more than roughly $510,000 per tank. The Pentagon selected two contractors to submit prototype designs, Chrysler Defense and General Motors. Both were given 3 years to submit their designs. So long as the two companies met the basic requirements, they were largely given the freedom to make trade-offs in areas such as mobility, survivability, and transportability. Both companies submitted their prototypes, each with different strengths and weaknesses. One of the key differences between the prototypes was the engine design. GM went with a more traditional diesel engine similar to the one used by the M60, but much more powerful. Chrysler's prototype used a modified helicopter turbine engine designed by Honeywell. Chrysler's decision to go with a modified aircraft engine to power a tank raised some eyebrows, as it had never been done before. But that did not stop Chrysler from pursuing a turbo-powered tank because it saw the advantages of using such an engine. It was smaller and lighter than a traditional diesel engine and produced very little visible exhaust. It was also quieter and easier to maintain because it had fewer parts. There were also obvious disadvantages to using a modified helicopter engine in a tank. There were no interchangeable parts with other tanks in the American arsenal, requiring the Army to maintain a special inventory just for the M1. Likewise, mechanics largely familiar with diesel engines would need to undergo highly specialized training to work on the engine. It guzzled fuel at an enormous rate. The engine also needed to pull in clean air for the engine to operate properly. Unpaved roads and open terrain create a tremendous amount of dust and dirt, so it needed to constantly scrub the incoming air to remove these kinds of particles. The US Army liked the General Motors prototype best and recommended going with that design. The Pentagon wasn't so sure. NATO was seeking to standardize as many components as possible among the tank models used by alliance members. As a result, the Pentagon asked both GM and Chrysler to modify their designs to support this initiative. Once the two prototypes were updated and tested, the United States went with the Chrysler proposal. Throughout its history, the Abrams has been repeatedly upgraded and enhanced to keep pace with technical advances. As a result, the United States has released three major variants: the M1, the M1A1, and the M1A2. A fourth variant was recently announced, the M1A3. To understand the differences between the three main variants of the M1, let's begin by talking about its initial design. The original M1 Abrams entered service in 1980. Coming in at 60 tons, the tank carried a four-person crew. The commander sat in the right rear of the turret. The gunner and the loader were also in the turret, with the gunner in the front right and the loader in the left rear. The driver was located in the center of the front hull. Its main armament was the M68A1 105mm rifled gun that could accurately kill enemy tanks at a range of 2,000 meters while on the move. It carried 55 shells in total and had a compartmentalized ammunition storage area with blowout panels that directed blasts away from the vehicle and the crew in the event of an ammunition explosion. The gun could fire at elevations between -10 to 20 degrees and was mounted on a 360-degree turret that could be turned manually or hydraulically. It had a laser rangefinder, a stabilizer, and a thermal imaging system. The digital ballistic computer automatically calculated firing solutions based on factors such as wind, range, and gun barrel droop. Other factors could also be entered manually into the computer to further improve accuracy. The entire system gave the Abrams a high first-hit probability. The Abrams also carried a 50-caliber turret-mounted machine gun above the commander, a 7.62 machine gun located above the loader station, and a 7.62mm mounted coaxially with the main gun. Last but not least, the original Abrams had two externally mounted smoke grenade launchers to obscure American movements on the ground. It could also generate a cloud of heavy smoke from its engine compartment by injecting a small amount of diesel fuel into the exhaust. The 1,500 horsepower 6-speed transmission had a max road speed of 45 miles per hour. The engine was so quiet that the tank earned the nickname Whispering Death because of its ability to quietly sneak up on enemies. The engine was extremely powerful, and the first generation of Abrams could accelerate from 0 to 20 in 6.1 seconds. Although optimized for aviation fuel, it could also run using gasoline or diesel, giving it additional flexibility. The fuel tank held 500 gallons, giving the Abrams a range of 275 miles. For such a large tank, the Abrams traversed the battlefield very well. It had an excellent suspension with front and rear shock absorbers. It could cross trenches as wide as 9 feet and was capable of moving forward on terrain with as much as a 60% grade and a side slope of 40%. What really separated the Abrams from its Soviet counterparts was its revolutionary armor protection, which significantly increased crew survivability. Its core armor was a top-secret variation of British Cobham armor technology, a special arrangement of metal plates, ceramic blocks, and open space. The outer steel plate could be penetrated by both high-explosive and sabot rounds, but the ceramic material was able to absorb vast amounts of kinetic energy. It was also able to disperse metal shards and hot gases in the armor's open spaces. A second steel plate behind the ceramic material provided an additional level of protection. The front of the tank was sloped at an 82-degree angle to help deflect incoming rounds. A side skirt helped protect the tank's suspension, wheel sprockets, and tracks. The original M1 was quite the tank, and nearly 3,300 were produced between 1979 and 1985. It did not have much of an opportunity to show its capabilities on the battlefield. That would be reserved for the second generation of Abrams, the M1A1. Actually, when people talk about the M1 Abrams, they're usually referring to the M1A1. This is the tank that demolished huge numbers of Soviet-made Iraqi tanks and other armored vehicles, including those fielded by its vaunted Republican Guard, in a mere 100 hours during Operation Desert Storm. It's hard to begin describing the M1A1 except for saying, wow. It's slightly larger than its older brother, 63 tons versus 60 tons, but its lethality took a big leap forward. It also supported better armor protection and upgraded electronics. As with the original M1, the M1A1 uses the Honeywell AGT-1500 multi-fuel gas turbine. It can reach speeds of 45 miles per hour despite its increased armor weight, but has the same cruising range of 275 miles. One of the biggest differences between the two tanks is the main gun. Instead of the rifled 105mm cannon used on the original Abrams, the M1A1 supports a 120mm smoothbore cannon, allowing it to fire larger rounds at a higher muzzle velocity. Not only that, the M1A1 fires depleted uranium shells, giving it greater penetrating power. The 120mm cannon also increases its firing range from 2,000 meters to 2,500 on the move. This range increase is significant because the A1 could now fire at opposing tanks while remaining well out of their range. This proved invaluable during the First Gulf War. Another big difference came in the form of increased armor protection. While the armor on the original M1 was excellent, the M1A1's is even better. It also employs Cobham armor technology, but designers added another level of protection, a layer of depleted uranium mesh. Depleted uranium armor is non-radioactive and has a density of at least 2.5 times greater than steel. Although this layer of depleted uranium did not make the armor on the M1A1 impenetrable, it could take a much bigger punch and remain operational. Not only that, designers lined the interior of the M1A1 turret with Kevlar, further increasing the chances of crew survivability in the event of a hit. The layer of depleted uranium plus the Kevlar did add 3 tons of additional weight to the Abrams, but what's a mere 3 tons between friends? So how do we know that the M1A1 was so good? While the original M1 participated in war games, it was never tested in battle. That would not be the case for the M1A1. In August 1990, the country of Iraq invaded its Kuwaiti neighbor without much of a fight. Iraq was no pushover militarily. It had the 5th largest army in the world, with nearly 1 million personnel. Not only that, it had thousands of Soviet main battle tanks. Iraq's armor force was primarily comprised of outdated Soviet T-55 and T-62 tanks. However, its elite Republican Guard fielded approximately 1,000 T-72s. The United States had built a coalition of many nations, each contributing to a massive buildup of men and machines along the Saudi border with Kuwait and Iraq. For its part, the Americans had amassed nearly 500,000 troops and thousands of tanks, including nearly 2,000 Abrams M1A1s. There was no question that the M1A1 outmatched Iraq's T-55s and T-62, but how would it fare against the T-72? 2 key tank battles answered that question. In the Battle of 73 Easting, 9 M1A1s, supported by 12 Bradley fighting vehicles, took on an Iraqi tank force comprised of T-62s, 72s, and armored personnel carriers. In a matter of 23 minutes, the Iraqis lost 50 tanks and 25 armored personnel carriers. Only 1 M1A1 suffered any noticeable damage, and that was caused when it ran over a mine. The largest tank battle of the war took place the next day at the Battle of Medina Ridge. In this battle, the American 1st Armored Division took on 6 Iraqi divisions, mostly from the vaunted Iraqi Republican Guard. The United States attacked using nearly 350 Abrams M1A1s, combined with aviation assets, artillery, and Bradley fighting vehicles armed with anti-tank vehicles. The Iraqis fielded hundreds of tanks as well, mostly T-72s. It's difficult to assess exactly how many of the T-72s were destroyed by the M1A1s, given that the Americans also fielded infantry and air assets in this battle, but certain facts provide insight into what happened. When the fighting started, Abrams commanders quickly realized that they significantly outranged their Iraqi counterparts, avoiding the need to close in on the opposing T-72s. Abrams crews reported that the 120mm main gun was highly accurate, and they had no problems penetrating the armor of the T-72 it faced. As the battle was fought under poor weather conditions, Army observers attributed the gun's high degree of accuracy to superior sights and other intangible factors. Several Abrams crews also reported that the tank's secret armor composition fared extremely well, suffering only minimal damage when they received direct frontal hits from Iraqi T-72s. These reports were supported by Abrams losses, or lack thereof, during the fight. Despite the presence of hundreds of Iraqi tanks, only 14 Abrams were damaged and another 9 were destroyed. Of those 9, none of them came as a direct result of being hit by the 125mm main gun on the T-72. 7 were the result of friendly fire, and 2 were intentionally destroyed after becoming stuck in the muddy ground. The Abrams armor was so good that not a single crewman was lost in the battle. In comparison, the United States destroyed 186 Iraqi tanks, most of which were T-72s. That's 1.5 tanks per minute. The Americans also destroyed another 127 armored vehicles. The Abrams only faced 2 issues of significance during the war. First was the tank's high fuel consumption rate due to the turbine engine. On its way to Baghdad, the United States had to make a strategic pause to allow supply vehicles to catch up with the tanks. The other issue was the need to frequently clean the air filters because of the sandy desert conditions. Tank crews did make some suggestions on ways to improve the Abrams, such as greater sight magnification and resolution, improved thermal viewers, and the need for a system to reduce friendly fire incidents. The United States built nearly 5,000 M1 Abrams tanks between 1985 and 1992. That year, it released the M1 the next generation of Abrams. The M1 which was later further upgraded to incorporate an enhanced systems package, is the most advanced Abrams to date. It's both very familiar and very different from the M1. In terms of similarities, the M1 retains the 1500 horsepower turbine engine used in the previous 2 models. It also retains the 120mm smoothbore main gun, the 50 caliber machine gun, and the 2 7.62mm machine guns. Externally, the M1 retains much of the same look as the M1, but looks can be deceiving. The armor on the M1 has been significantly improved. In previous versions, only the front armor of the tank incorporated the depleted uranium mesh. In the new Abrams, the turret and side armor have been upgraded to incorporate depleted uranium to reduce the chance of penetration by rocket-propelled grenades and other man-portable rocket systems. Furthermore, the designers coated the mesh with a layer of graphite throughout the tank to strengthen the entire tank. The armor below the tank was also improved to reduce damage caused by mines and IEDs. Improved armor increased the weight of the tank to upwards of 70 tons, 10 tons more than the original M1. The added weight of the armor reduced the road speed to 42 miles per hour compared to 45 miles per hour in earlier versions of the M1. Where the M1 really shines is its upgraded electronics and its tremendous advances in technology. It is an all-digital tank with new displays that provide the commander and crew members with better understanding of the tank's operational status. The tank commander has been provided with an improved weapons station, an all-weather independent thermal viewer, and a position navigation system. With this positional navigation system, the Abrams M1 can identify its location relative to other friendly units. Drivers have been provided with an upgraded picture-in-picture digital display. In addition, the gunner's primary sight has been further stabilized to improve the already impressive accuracy of the Abrams smoothbore 120mm cannon. The tank's lethality has also improved through the addition of an ammunition data link that allows the tank to use multi-purpose rounds. This means that shells can be programmed to explode in different ways, such as on contact, in the air, or on delay. As the Abrams is now digital, improvements were also made to its internal power system. In past Abrams variants, the entire tank, including electronics, was powered by the turbine engine. If the engine was not running, simple actions such as moving the turret in a different position were not possible. To solve this challenge, designers added a compact auxiliary power system. Capable of generating 10 kilowatts of electricity, this single-cylinder diesel engine produces enough power to keep the tank's electronic systems operational without the main engine running. It's also very fuel efficient and can operate on most types of diesel. Another innovation is the M1 ability to automatically reroute electric power to various components in the event of damage to a conduit. Designers made this possible by incorporating a multiple bus system that automatically redistributes electricity to a component by using an alternative path. The M1 communication capabilities have also been improved through the addition of a joint tactical radio system. This system allows for the integration of handheld, manpack, and small form-fit dual-channel radios that allow communication between soldiers on the ground, mounted platforms, and headquarters. In terms of electronic self-protection countermeasures, designers added an ANVLQ-12 Crew Duke Counter-IED system. This system can electronically block enemy radio transmissions used to detonate roadside bombs, protecting the tank from improvised explosive devices. While the Abrams M1A2 is currently recognized as the top tank in the world, the Russian T-14 Armata is no slouch. Although beset with technical and production challenges, it puts Russia's T-72, T-80 and T-90 to shame. Let's take a look at it. The T-14 is Russia's future main battle tank. It's based on the Armata Universal Combat Platform, which is a modular tracked vehicle that can be modified to create several different types of vehicles. Not only can it be used to construct T-14 and other tank models, but it can also be converted into infantry fighting vehicles, tank support combat vehicles, self-propelled artillery, combat engineering vehicles, and armored recovery vehicles. There are also plans to create a mobile air defense system from the base platform. Russia intends to use the Armata Universal Combat Vehicle to replace its current fleet of T-72 tanks and its BMPs. Designed by the Russian defense company Uralvagonzavod, from 2013 to 14, the T-14 made its first public appearance at the Moscow Victory Day Parade in 2015. State trials began in early 2020, and the tank may have briefly taken the battlefield against Ukraine in April 2023 to test it in real combat conditions, though that has not been independently confirmed. In terms of specifications, the T-14 is powered by a 12-cylinder 1500 horsepower diesel engine with a road speed measured between 50 and 55 miles per hour. It has an 8-speed automatic transmission, 7 forward and 1 reverse. It has a range of approximately 310 miles. Its impressive range and speed are likely due to its lighter weight at 55 tons. The Armata can handle gradients as high as 60% and side slopes of 40. It can also cross trenches as wide as 9 feet. The Armata carries a crew of 3, all located in an armored compartment at the front of the tank. The driver is positioned on the left side of the forward compartment. The gunner sits directly in the middle and the commander on the right. Each crew member has an individual hatch to enter and exit the vehicle. If all of the crew members are in the front of the tank, who's in the turret? Who loads the shells? Well, the answer is no one. As with the design of the T-72, T-80 and T-90, the Armata uses an autoloader, allowing for a smaller crew than tanks like the Abrams. It carries 45 rounds, with 32 shells in the autoloader. The T-14 was not the first tank to incorporate an unmanned turret, but most designs that incorporated this feature never moved beyond the prototype stage. The use of an unmanned turret significantly improves crew survivability, even when the tank is fully penetrated by an enemy round. Another benefit of an unmanned turret is that no space is needed to house the crew members. This allowed the designers to reduce the silhouette of the Armata, making it harder to spot, both on the battlefield and under concealment. In terms of armor protection, the base armor on the Armata is comprised of steel, ceramics, and other materials similar to the Abrams Cobham armor. On top of the base armor, the Armata also has Malachite add-on explosive reactive armor to the front of the tank for further protection. Designers added slat armor to the back of the tank to make it less susceptible to rocket-propelled grenades. In terms of passive protection capabilities, the Armata uses radar-absorbent materials to make it more difficult for ground search radars to detect the tank. It's been said, but not confirmed, that the Armata is also using materials on the tank's underbelly that are less likely to set off magnetic mine fuses. The Armata also employs the Afghanet protection system to destroy incoming missiles and rockets at distances of up to 50 meters. The Afghanet system has sensors that detect incoming threats and a specialized computer to determine the likely impact point. Once that's been calculated, the Armata automatically tries to disrupt the projectile's guidance system by electronic means and fires a blast of metal shards, much like a shotgun, in the air to destroy missiles kinetically, all within seconds. The T-14 Armata is armed with a 125mm smoothbore cannon with an estimated range of 5 kilometers. Not only can it fire several different types of shells, including heat, sabot, and airburst cluster munitions, it can also launch long-distance laser-guided missiles at tanks and low-flying helicopters at a range of 12 kilometers. Its secondary weapons include a 7.62 machine gun and a 12.7mm heavy machine gun, which is equivalent to the American 50 cal machine gun. There have also been some sightings of T-14s carrying a 57mm automatic grenade launcher instead of the 12.7mm machine gun. As all of these weapons are mounted on the turret, they are operated remotely. The advantage of this approach is that crew members do not need to expose themselves to potential harm to fire the T-14's secondary weapons. Now that we understand the capabilities of the Abrams and the Armata, which one is the superior tank on a modern battlefield? To make a fair comparison, we need to level the playing field. Factors such as production numbers, technical and manufacturing challenges, previous combat performance, and crew training will not be considered. We will, however, compare these tanks on how they would perform in modern warfare, using the conflict in Ukraine as the basis, starting with maneuverability. Today's battlefield is reminiscent of the First World War, with its extensive trench networks and the widespread use of artillery. Progress is measured in meters, not miles. Extensive use of tank obstacles, such as Dragon's Teeth, prevent tanks from moving swiftly across the battlefield. Neither the Abrams nor the Armata have sufficient ground clearance to run over a 4-foot obstacle. The Abrams has a ground clearance of 19 inches. The precise ground clearance on the Armata is not known, but with certainty, the Armata cannot roll over a 4-foot obstacle. The use of anti-tank ditches is widespread in the Ukraine war. Both the Abrams and the Armata can cross trenches up to 9 feet. Unfortunately for both tanks, anti-tank ditches in Ukraine can be up to 19 feet wide and 13 feet deep. Neither tank can overcome ditches of such a size. Maneuverability is more than just how well a tank can move across a battlefield. It also includes the ability of tanks to reach the battlefield itself. Again and again, we have seen rows of destroyed Russian tank columns along Ukrainian roadways long before they reach where the actual fighting is taking place. The T-14 Armata is significantly faster than the Abrams, with a road speed of at least 50 miles per hour or more. In comparison, the heavily armored Abrams lumbers along at 42 miles per hour. But does that really matter? Probably not. The Ukrainians utilized drones and other precise weaponry to destroy the first and last tanks in a column formation, typically from above. The other tanks in the column must try and maneuver around the destroyed tanks, which they cannot do quickly. This gives the Ukrainians time to deploy artillery to destroy the other tanks in the column. Yes, this is a question of tactics, but the fact is that the Russians continue using tank columns despite experiencing heavy losses throughout the war. There's no indication that Russia will change its approach, and the T-14 is likely to travel in columns as well. Taking this into consideration, the Armata's speed does not give it any advantage over the Abrams. So far, neither the Abrams nor the Armata have any advantages over the other in the category of maneuverability. There is, however, a significant difference in operational range. The Armata can travel 310 miles without refueling. The Abrams M1A2, with its gas-guzzling turbine engine, only has a range of 265 miles. Although the superiority of American logistics probably could mitigate the difference, based on a tank versus tank comparison, the Armata clearly outranges the Abrams. Although both tanks are very similar when it comes to maneuverability, the Armata has an important advantage over the Abrams because it can travel longer distances between fill-ups. Winner, T-14 Armata. Now let's talk about armament. The M1A2 Abrams has a 120mm smoothbore cannon, with an effective range between 3,000 to 4,000 meters. In comparison, the Armata has a 125mm smoothbore with a range of 5,000 meters. In terms of punching power, both tanks are similar, with any difference coming as a result of the effectiveness of the round's design. In terms of effective weapon range, the Armata has a huge advantage over the Abrams, and that doesn't even consider the Armata's ability to fire laser-guided missiles at even greater distances. So the Armata is far superior than the Abrams in this category, right? Well, not so fast. Remember, we are comparing these tanks on a modern battlefield, not on a gun range. Except for open terrain such as a desert, the ability of either tank to fire at its maximum range is unlikely. There are a variety of obstacles that visually obscure targets, such as wooded areas and well-developed fortifications, making it difficult for tanks to face off against each other at their maximum firing range. So distance is not a great way to measure the effectiveness of either gun. What matters more is accuracy, which is determined by the technology used in the tank. Both tanks employ the same basic visual aiming methods, such as rangefinders and thermal viewers. The big difference is the technology used in fire control systems, visual sights, and gun stabilizers. The tank with the most advanced technology has a clear advantage over its opponent. Given the secrecy around the Armata's technological capabilities, we cannot determine whether the T-14 is superior to the Abrams in this category. We must look at it differently. The United States is a global leader in developing and improving military technology. It would be difficult to find another country that can keep pace with American military technology. While we do not have any hard data that supports our conclusions, we feel confident that the Abrams can fire rounds with greater accuracy than the Armata. Winner: M1A2 Abrams. But how does it fare when it comes to armor and protection? This is a difficult category to assess. Armor on the Abrams and Armata follow the same basic design principles of combining steel, ceramics, and other materials to protect against kinetic and explosive attacks. Both the United States and Russia are highly secretive about their armor technology, and it's impossible to tell which one might be better. Armor thickness is not a good way to assess effectiveness anymore. It might have been when everyone used steel, but that's no longer the case. We can assume that the frontal armor of both tanks is more effective than their turret or side armor. It's also fair to say that the weakest point on both tanks is the top armor. The use of reactive armor on the Armata does not play a role in comparing the two tanks. The Abrams has the same capability, though generally not used. Where the Armata does stand out is its ability to automatically deploy countermeasures to thwart incoming rockets and propelled grenades. This has caught the eye of American military leaders who are currently assessing if a similar feature should be incorporated into the Abrams. What about the unmanned turret? Does that give the Armata an advantage? Not at all. The unmanned turret certainly increases crew survivability, but does not improve the level of overall tank protection. If anything, it actually may decrease the ability of the T-14 to survive on the battlefield. It's widely believed that armor on the Armata's turret has been kept to a minimum to save weight. Some claim it's only strong enough to stop autocannon fire. Others believe that with its low turret silhouette, it's difficult to hit the turret from either side. Neither matter. The real threat to tanks in modern warfare are weapons that can strike from above, such as attack drones and man-portable missiles, such as the Javelin. Why is that important? It's important because the T-14 Armata uses an autoloader for its main gun. As we've seen in Ukraine, it's not uncommon for Russian tank turrets to explode when hit, often flying off the tank completely in a catastrophic explosion. This is due to the lack of adequate protection for the shells stored in the turret. By minimizing turret armor to reduce the weight of the tank, it's likely the Armata will suffer a similar fate. Although the ability of the T-14 to deploy countermeasures against incoming missiles is interesting, we believe that the lack of adequate turret armor is a proven liability. Winner: M1A2 Abrams. Whether or not the T-14 Armata is an Abrams killer is not important. As the war in Ukraine has shown, tanks are not as important as they once were. They have largely become long-range infantry support vehicles that allow ground troops to move forward under the cover of their fire. The days of tank breakthroughs are over. It's simply too dangerous for tanks to close in on enemy positions, and that doesn't even take into account the many anti-tank obstacles that severely limit battlefield mobility. The United States is currently in the process of transferring 31 M1 A1s to Ukraine. They have been promoted as a game changer, that they will crush enemy units on the battlefield, allowing a much-needed breakthrough. Although it's possible, it is unlikely. They too will likely become infantry support vehicles. Shouldn't the M1 A1's much-touted armor provide the Abrams with sufficient protection on the battlefield? Not exactly. Ukraine is receiving the export version of the M1 A1, which is purposely downgraded so that it's not the equivalent to the Abrams fielded by the US Army. Armor on the export version of the M1 A1 does not include the depleted uranium mesh, making it significantly weaker than the American version. Only time will tell. What do you think? Will the Abrams make a difference in the war in Ukraine, or will it become just another infantry support vehicle on the battlefield? Share your thoughts in the comments section below.